Well, good afternoon, everyone. Thanks for coming late in the day. Really excited to be here celebrating 10 years of serverless and containers at AWS. My name is Nick Colt. I'm Director of Product for Serverless Compute at AWS. I'm going to be joined later on the stage by my colleague Usman, who's Director of Lambda. And then we have a really excellent story from Catherine at Capital One talking about their journey with serverless. So really excited for you all to be here. If there's one thing that I want you to take away from the discussion today about serverless, it's this concept here, which is about speed. In the world today, you think about all the things that are changing, and if you're running a business or an enterprise of any kind, you have to be prepared to adapt to change. And the faster you can respond to those changes that happen in the world, the more likely you are to be successful. And that is the core mission of serverless, is to help you be successful by helping you move faster, to go faster from idea to production. So just keep that in mind. That's like the core driving mission behind serverless, and it's going to permeate this whole presentation today. So you're probably familiar with the term serverless. I mean, it's been out there for 10 years now, but I wanted to talk a little bit more about how we think about serverless, what our mental model is for serverless, and hopefully you'll find that helpful as you think about your serverless journey. So if you think about software running in the cloud, there's a whole stack of things that are necessary in order for an application to actually run. And that stack of things includes the physical infrastructure. It still exists even when you run in the cloud, right? We're just managing it for you. And with serverless, how we help you move faster is by enabling you to focus on the higher levels in the stack and not spend time on the lower levels in the stack. And so one of the terms that we use when we talk about that is the undifferentiated heavy lifting, or the undifferentiated operational tasks. And what does that mean when we say undifferentiated? It really means, is the thing that you have to do actually adding value to your business in a way that's unique to your business? Because if it's not, then it's not really differentiated, and you really have to question why you're spending time on it. And so with serverless, we take away the undifferentiated heavy lifting by managing all of the things that are lower in the stack so that you can focus ideally on the very highest level of the stack, which is the business logic. Write code for business logic, and we take care of everything else. And that's really what serverless is all about. And so that's kind of one way to define what serverless is through this the stack. So today, I'm not talking about all things serverless. There are a lot of things that fall under the serverless umbrella. There's compute, there's databases, and other things. Today, we're talking specifically about serverless compute. And the services that we're talking about are Lambda, which is kind of the original serverless compute service, as well as Fargate and ECS, which are more focused on the container model. And then we have workflows and integrations, so EventBridge, which is a serverless event bus, and Step Functions, which enables you to run workflows. And so that's kind of where the focus is today. And I mentioned that Lambda is kind of what kicked off serverless. So back in 2014, we launched AWS Lambda in preview. We also launched Elastic Container Service at that same time in preview. And we've done a bunch of innovations since then, and this slide kind of highlights not all of the launches that we've done, because there have been many more, hundreds of launches that we've done over the last 10 years, but we've done a bunch of things to help you move faster, and a lot of those innovations have been centered around things like adding storage capabilities, adding compute capabilities, adding better observability tools, and better developer experiences. And if you look at this list of things, a large percentage of them came from having conversations with you. We talk about customer obsession and working backwards. And what that really means is we go out and we talk to you at places like reInvent and other environments, and we hear from you, we hear the problems you have and the pain points, we hear the things that stop you from moving faster, and we go build solutions to those. So when you go and you read this list of things, most of them came out of those kinds of conversations, and the kind of conversations that we're having here at reInvent with all of you this week. We're not done. This is just the beginning. It's still day one for serverless, but it's been 10 years, and we've done a lot, and we've got a lot more coming, and we've got some things we launched recently that you're going to hear about today as well. So 10 years ago, we launched serverless. Today, we have customers of all shapes and sizes using serverless. I wanted to share some of these numbers. They're kind of mind-boggling, the scale. Like tens of trillions of Lambda requests processed each month. That number is almost too big to comprehend. Most customers are not going to get to tens of trillions of Lambda invocations per month. But even if you're small, even if you are a very small customer, the thing you want to take away from these statistics is that you benefit from all the experience that we had to go through in making these services able to operate at that scale. We have a saying that we use sometimes, there's no compression algorithm for experience. And what that means is, you have to learn some lessons the hard way. And we've learned a lot of lessons over the last 10 years about how to operate these services at this scale securely with high resilience and availability and performance. And so when you adopt serverless on AWS, you're getting the benefit of that 10 years of hard-learned and earned lessons that we've gone through on your behalf, and you don't have to do anything to get those benefits other than start using the service. Okay, so we've talked about the introduction of serverless, the serverless compute, the serverless stack. So I want to briefly summarize 4 core principles of serverless. And I'm going to talk about the first 2, and then I'm going to hand it over to Usman to talk about the others. And along the way, we'll talk about some of the services within the portfolio in more detail, as well as some of our recent launches. So the first one, abstracting away complexity of infrastructure management. That's kind of a mouthful. What does that mean exactly? What are we talking about? Well, an abstraction is putting a bunch of things together into a new concept, a new construct. And when we launched Lambda, we introduced a completely new abstraction for running code that really didn't exist before Lambda, which is the idea that you can write your code in the form of a function and then just run it in the cloud. You go from code to running that code with nothing in between, with no servers, with no clusters, with no networking configuration. It's been 10 years, and if you're a Lambda user, I'm sure that concept is familiar. But it's hard to overstate how new that concept was back in 2014. The idea that you didn't have to have a server to run your code. And so that was a new abstraction, right? That is abstracting away a whole bunch of complexity. When you package up that code into a function and run it, all of the things that you're not managing and all of the stuff that goes into that, and there's a lot of things that go into that to make that happen, that's a new abstraction that takes away complexity. And by doing that, that improves developer agility, because now a developer who wants to try out an idea doesn't have to go figure out which instance they need to run it on. Do they have to go create a cluster? How are they going to scale it? No, you just write your code, you pick your language runtime, write it, run it. The ability to go from idea to production is greatly simplified. You actually get a bunch of performance benefits as well, because we're managing the scaling for you, because we do tens of trillions of Lambda invocations per month. We know how to scale up really quickly. You don't have to think about scaling. Just invoke your function, and it runs when it needs to. And so you get performance benefits. Security is one that maybe isn't as obvious. But when you use a Lambda function, you write your code for Lambda, you're using Java or .NET or Python, we actually manage patching the vulnerabilities in that language runtime for you. So if there's a vulnerability that gets published, we go ahead and make sure that all of the functions that are using that runtime, that language, are running with a patched version so they're not exposed to that vulnerability. That might not sound like a big deal, but if you don't have that, then you're either exposed to that vulnerability, you really don't want that, or you have to go through the work of making sure that you go update that. Or maybe you as the developer don't, but your security team is coming and yelling at you and telling you, hey, you're not using the right version of the language. You don't have to do any of that with Lambda. So that increases agility because there's just less work to do. Cost efficiency also, because of this built-in scaling and the pay-as-you-go pricing model, you can do a proof of concept at extremely low cost and then scale up and pay as you go as you scale up. So this abstraction of Lambda and the Lambda function just really dramatically changed the equation in terms of agility and speed and getting to market. Now, around the same time that Lambda was introduced, containers were really taking off. And for those of you who remember the world before containers of like, well, I don't understand, it works on my laptop, why doesn't it work on the server? Like, containers solved that problem. Package all your dependencies up in a consistent way, have a consistent runtime environment. And so it was a super popular way to run software. But a container itself is not enough. You need a way to actually manage running many containers all at the same time across many hosts. And so ECS, when we introduced it, solved that problem for you. Some of the similar benefits to Lambda, but with a sort of lower level container model instead of the function model. But what really changed things for containers was when we introduced Fargate. So if you're not familiar with Fargate, Fargate is a serverless compute engine for containers. So it's what's really interesting to customers about Fargate is how it combines something that sort of feels like a server, like you run your container and you get a host and the container runs and it's got a Linux kernel and it can do pretty much anything that you can do on a regular machine. But you don't have to manage a server, you don't have to scale a cluster, you don't have to patch an operating system. So it's combining the benefits of serverless with that more traditional container programming model. And you actually pay for the containers and not the host that it runs on. So it has a more serverless pay-as-you-go model. It has similar benefits to Lambda for security as well, because you're not responsible for patching that operating system. If there's a vulnerability in the operating system, we take care of that for you. You don't have to think about it. And so this was an innovation that really changed how people thought about containers and introduced the idea of serverless into the container world. And we've seen Fargate just become immensely popular since then. This is an example of a launch, a pretty big launch that we did in 2024 with Fargate and ECS. So I mentioned how over the years we've been investing in all of these improvements to make it easier to move faster and build your applications on serverless. And code is not enough. You need storage, you need databases, you need networking to build a real application. And so in early 2024, we launched an integration with Elastic Block Store. So previously, you could only attach an EBS volume to an EC2 instance. And you could use that EBS volume in containers running on that instance, but you still kind of had to go manage the instance and manage the volume separate from your containers. And what we did is we said, well, we don't want you to have to worry about hosts and about managing volumes. So let's actually provide an interface in ECS that enables you to use those volumes directly. And so this was a really, really cool innovation in the serverless space for serverless containers. The second principle I want to talk about is composability and writing less code. So we had these abstractions that we introduced for Fargate and for Lambda. I didn't mention the ones that we have for EventBridge and step functions, but those have similar abstractions. You want to be able to take abstractions, sort of building blocks, and actually piece them together to create an application. And with serverless, when you do that, you can actually write less code. How? How do you write less code? By composing? Well, think about something like I have a queue and I want to process things coming off of that queue. In a more monolithic world where you're writing a code as a monolith, you can have a queue and you can have a processing engine for that queue, but you're going to have to write the code to manage the queue yourself or use a library and make sure that you got enough memory on the machine to handle the queue. You're going to have to write all the triggers and handlers and everything and make sure that you got enough processing power to process that queue. All of that stuff is code that you're having to write. With serverless, you can put together a queue, an SQS queue, and a Lambda handler for that queue, and all you have to focus on is making sure you get the code right for handling that queue entry. So there's less code by composing these things together. We actually have this really nice framework, open source framework and tool called the serverless application model that makes it really easy to compose together serverless applications by taking these primitives like functions and queues and event buses and putting them together into a serverless application. And not only that, but you can actually build and test parts of that locally. You can deploy it to the cloud really easily with a CLI, and it actually deploys it as infrastructure as code. You can monitor this stack while it's running, live tailing the logs. And so the serverless application model is one of the ways that we make it easy to compose components together and write less code, because by composing, you're actually putting a lot of the business logic into your architecture and not into your code. Step functions is another really cool serverless service whose kind of mission in life is actually all about composability. So what step functions does is it enables you to run workflows, which is really like almost like a flow chart, a state machine. We actually call it a state machine. And it handles the logic and the retries and the error handling, and it integrates with a bunch of different AWS services, including Fargate and Lambda. And so step functions through a state machine actually ties together a whole bunch of different serverless and other AWS services, allowing you to compose serverless workflows and a whole lot less code that you have to write. And these things are amazing. They can run for weeks or months at a time. And we just launched right before reInvent a really nice enhancement to step functions called simplified state management. And basically, if you have a workflow and you've got variables defined in that workflow, this makes it really easy to propagate those variables through and do things like data transformation on those variables. It's a really nice developer experience enhancement. Of course, the code that you do write is super important. We don't want to de-emphasize that writing code doesn't matter. It matters a lot. And AWS is very heavily focused on making it easy for you to write code. We have things like Amazon Q for developers, which is amazing. For Lambda, we actually launched some really nice enhancements for IDE integrations with Lambda. So if you go into the Lambda console, you can now write Lambda functions in the console using VS Code. So if you're familiar with VS Code, you get that in the console. We also have a really nice local IDE integration that's got things like queue integration and a bunch of like troubleshooting and getting started suggestions. So I encourage you to check that out if you're a VS Code user. It's a really nice enhancement that we launched recently. And that's not the end. Developer experience is super important for us, so we got more things planned there. Now with that, I'm going to hand it over to my colleague, Usman, who's going to tell you about the other two serverless principles, and he's going to dive into some of our other recent launches as well.
Thank you, Nick. Hi, folks. Thank you. And thank you, Nick, for walking us through the first two principles. Folks, I'm Usman Khalid. I am the general manager for Lambda. I've been with AWS for a little over 11 years now. I've been involved with the serverless teams. I was part of the step functions and EventBridge launches. And before that, I used to run a little-known service called EC2 Autoscaling, which used to power Lambda and was the most cloud, the most flexible way of building applications until Lambda and the container revolution happened. Now, Nick talked about abstracting away infrastructure. He talked about writing less code. And he hinted at the architecture as well. But one of the superpowers of how we get that speed for you is around the architectures you are able to build and use in serverless programming and the serverless programming model itself, which are designed for extensibility and ease of integration from the get-go. And by that, I mean is that not only are you able to meet the requirements of the thing, the business logic or the business problem you're trying to solve at that point, or the problems you can anticipate, you are potentially setting yourself up when you choose this technology stack to actually handle the problems you cannot anticipate in the future. And it obviously all starts with what composes the architectural pattern. So where we start with the architectural pattern, we are starting with the Lego blocks. Some of them Nick talked about, like EventBridge and step functions. Other ones are, for example, APIs or API gateway, where you're still defining your APIs. You're connecting your Lambda functions or your microservice effectively. In the example here I have on the slide, the Lambda functions are effectively microservices. You're connecting them through messages or events. And when you need that orchestration, when you need something to work kind of together or fail together, you use something like a workflow and step functions. And this composability is what also leads to the extensibility. And so one of the most extensible ways of building serverless architectures is event-driven architectures. We have seen an immense interest from customers and immense growth in these form of architectures simply because of how evolutionary they are. The producers never have to talk about the consumer to the consumers. And I had the privilege to be part of the team that launched EventBridge, where EventBridge is a service that we specifically designed to help customers build event-driven architectures super easily on AWS. And EventBridge has a series of capabilities like event buses, which can connect many producers to many consumers, pipes that can connect one-to-one, and a schema registry to track what your events are. All of these things have the AWS best practices built into play to build event-driven architectures easily. Now, these are asynchronous architectures. There are trade-offs. I'll be talking about some of the cool launches that make these architectures easier to manage and operate as well. But that power of extensibility is what really, and then evolutionary architectures is what really helps customers not move fast when the idea first gets to production, but to continue moving fast after the first launch as well, as they iterate and then they figure out how to grow their business or their idea. Now, what EventBridge does is that it matches an event to a rule and calls an API. Your consumers are always API. So sometimes developers think about event-driven architectures, they get a little worried that, oh, I'm not going to be having any APIs. What about my API-based microservices? Effectively, what EventBridge is doing is that it matches an event to a consumer that is listening to it and calls an API. Now, the API previously could be an AWS service. It could be a SaaS API. Think Salesforce, think Zendesk, think PagerDuty. What I'm happy to announce is that just 3 days ago, we launched the support for private APIs. The in-step function and EventBridge powered by resource endpoints in AWS Private Link. And what this capability enables you to do is now call APIs that are inside your VPC. These could be microservices that you yourself have built and not exposed to the internet, and APIs that are actually on-prem. Because many times, surprising for me as well, actually, over the last few years, is customers use event-driven architectures to actually modernize. I've talked to customers who've taken mainframe applications, and they use the strangler pattern on an event-driven architecture to take away functionality one by one and decompose it into microservices, all triggered by events. They need some of that functionality to still live on-prem until they finish this migration. And so this capability, they no longer have to be restricted to just everything running in the cloud or everything running as a SaaS API. Again, you're not managing integrations, you're not managing shims in the code to figure out how to connect your different applications together. Less code to write, and all guaranteed by the security and the compliance rules available in Private Link, so your data never leaves your network. Obviously, with Lambda, Lambda as a higher order abstraction. You really don't think about the network so much when you're designing your APIs or you're designing your microservices. But with container-based applications, you do. You do need to figure out what's a DNS name, where is the port of the container that you want to be able to send your request to. And so a few years ago, we launched this capability in ECS called ECS Service Connect. And with ECS Service Connect, you could get a application-friendly name for your service, which other application code can invoke. You got amazing health check and retries and monitoring for your services that are talking to each other within the same cluster. And customers really appreciated the fact that they didn't have to do this extra work on how to actually connect and, again, compose their architectures, even on containers. And just a few weeks ago, we actually extended that capability by integrating ECS natively with VPC Lattice. And what that enables you to do is not just be able to, in an easy, friendly way, connect services running in a single cluster. You can now go talk and connect services which are running across multiple clusters and VPCs. And because you're using VPC Lattice target groups, you no longer need to use an ALB or a load balancer in the middle to get the networking right. Again, a greater simplification to your architecture and just less things to manage as you go along. Now, that was all around architectures, extensibility, evolutionary architectures. I want to talk about the fourth principle that really helps people move fast. Now, even with serverless, it's a shared responsibility on how to keep your application available, how to keep your application secure, how to keep your application performant. But as Nick mentioned about the sheer amount of experience that we've had over the last few years in doing this thing, these products, by their very design, take on more of this responsibility. You still have things to do, but way less things to do. And oftentimes, just peeling the curtain a little bit for you folks as well, like when our software engineers are building software, it's often not the coding that is the long pull for us. It's actually the scaling, the testing, the performance of the code, and getting it operationally ready and secure. That takes often way longer to do. Now, with serverless applications, that is something that you can get a lot faster on, and there's a lot less to do. And I've been a customer. EventBridge itself, many parts of EventBridge work on Lambda and work on Fargate today. And in a small team of engineers, we were able to innovate so much over the last few years simply because we bet on ourselves. So let's start diving a little bit here. So starting with availability, all of our services that Nick talked about respect the regional boundary. We don't have cross-region dependencies. We are architected to withstand an AZ, impacted AZ. We are multi-AZ by default. We carry capacity on your behalf, so you don't have to think about capacity planning across AZs. And so there's never an issue there. And then the last little bit on this slide is what I would like to highlight on is cells. And over the last 10 years, we've really focused on cellular architectures. Oftentimes, customers think about, or developers, when they think about cellular architectures, they think about blast radius reduction. But what cellular architectures have really helped us achieve is those tens of trillions of invocations per month. Because what we can then do is we can test our software instead of testing our software to the size of US East 1, we can test our software to the size of the maximum cell size that we have and make sure that our software is reliable as we roll it out, and we make changes in a smaller chunk. So any blast radius of change is much more limited than a single region. And then finally, security. Starting from the bottom here, we invented, for example, the micro VMs called Firecracker. It's an open source technology. It's almost sci-fi now when you think about it 6 years later, but basically what this enables us to do is run these really, really tiny micro VMs that can spin up in sometimes less than a second and have the full security boundary of a virtual machine. And they're running on EC2 instances that have the Nitro system that is known for its hardened security. None of our operators have access to your code, access to your data. It's completely impossible for any of us to access that. At the higher level on top of that, with your data, with the data flowing into our system, it's encrypted completely at rest and in transit, often using your own keys, optionally using your own keys. And then we support the customer-managed key encryption for all of our artifacts and resources. And all the way to the application level, where we support code signing to ensure that the code that you provided us is the one that is going to be executed, and granular permissions about how and who can access your resources. And then finally, the big thing with security is that there is no box for an attacker to attack. We are constantly cycling the micro VMs. We're constantly cycling the underlying EC2 instances that those micro VMs are running on. So the security footprint, or the footprint, or your infrastructure footprint is almost negligible. It's almost like a stealth airplane where no one can see it. But that doesn't mean that we don't want you to see it, and we don't want you to have observability on what's happening within your application. So one of the things that I'm super excited to announce, that we just announced recently, is application signals for Lambda. This is our first stab at building an application performance software in CloudWatch. And with this software, going back to writing less code and having time to market, your developers don't actually have to instrument the code. Out of the box, you get OpenTelemetry, standard telemetry. You get metrics and logs and traces to figure out where things are happening within your architecture. You get metrics for errors, request volume, latency, and faults. And then they're all deeply integrated, so we're clicking on a single error can tell you which Lambda function or which part of your architecture is experiencing these errors or contributing to these customer-level faults. And then you can drill down into application logs literally within seconds to figure out what's happening. And some of you might have already noticed some of the launches we had today, where you can now use Gen AI tools in Amazon Q to actually even automatically figure out from your logs what has changed in your code or what has changed in your system. So we're super excited about that. We're super excited to hear more feedback from customers about as they use it as well. This is super new. And we also launched Container Insights for observability in ECS as well. With this particular launch, what we've done is we've packaged our own best practices, the metrics we monitor. Amazon is a huge user of Lambda and ECS as well. We have packaged our own metrics, the metrics we use to operate and provide high availability to our applications to customers as well, so they don't have to figure out the best practices themselves. You can start at the cluster level or at the account level, and then basically ultimately extend this to be the full single pane of glass for your entire organization. You can see all the container services that are running in your organization and how they're doing. And then getting to performance now, I was part of the team that launched EC2 predictive autoscaling in 2018, so I'm super excited that we launched at reInvent, predictive autoscaling for ECS as well. This doesn't use generative AI. It uses machine learning to look at your load metric. Your load metric, for example, could be requests per second coming into your ALB. It looks at historical load, and it looks at your scaling metric that you can use in step scaling policies or target tracking policies. Normally, the most popular one is CPU. And it figures out how many minimum tasks you need at any given time based on historical load for future load workloads. This thing's been working great for EC2, and we're super excited to bring it to ECS services and Fargate-based services as well. Effectively, you're scaling ahead of time. And with predictions, you can only be less wrong. These things work perfectly with reactive scaling policies as well. So if you have an unexpected burst that was not predicted, you're still catching up. And we're launching the instances that you need to serve those requests. Now, SnapStart is something we launched in 2022. Going again back to like how we are taking the shared responsibility or more of the shared responsibility for performance and scaling and availability from developers. This is a checkbox that you have to turn on your Java-based functions to say, hey, I wanted to use SnapStart. And can use your cold start times. Cold starts are when a new invocation of a Lambda function is spun up or a new execution environment is spun up. We are able to then serve that request 10 times faster, oftentimes sub-second latency to start up a new execution environment or a new micro VM. I'm super excited to announce that just a week or so ago, we extended the support for SnapStart for Python and .NET runtimes as well. And just to kind of peel the covers a little bit here as well, what we're effectively doing with SnapStart is when you give us your function, we actually initialize the function and use your initialization code, load all the libraries that you're going to be using in your code, and then take a snapshot of the entire memory. And then next time we have a request that needs to do a cold start or do a new execution environment, we restore that environment with that snapshot. And that means your code is ready as fast as possible. It is ready to handle the request and be able to process what's coming in. And then finally, speaking of performance, we've heard a lot from customers about Kafka. Kafka, we talked about event-driven, but Kafka also is a super popular way customers are building event-driven architectures or doing data streaming. We've heard a lot from customers that, hey, they want to use Lambda. Lambda is effectively, when you think about a Lambda function, you're writing an event handler. It's quite literally the code from a product designed to process events. They want to use more of Lambda, but oftentimes Lambda scales so quickly that the actual Kafka code doesn't respond or has issues that it has to repartition itself to handle the scaling. So we took on that challenge and we said, okay, what can we do to actually still deliver the scaling of Lambda for Kafka-based workloads as well, especially when customers have these SLA-bound workloads. They're listening to a topic and they really want to process all the events in the topic within a given SLA. So we basically launched Lambda provision mode for Kafka. All customers have to do is specify a minimum and a maximum number of provision pollers that they would like. We efficiently scale 10 times faster than our previous Kafka integration. But more importantly, we efficiently scale these workloads so that, or these pollers, so that when they come up, they don't impact the Kafka broker performance, and then you're able to meet your SLA on time. Speaking of customers, I'm super excited to hand off the discussion to Catherine to tell us about her story and Capital One's story about how they have been on the serverless journey with us. Thank you, Catherine.
Hi, everybody. It's great to be here. Thank you to Nick and Usman. It's super exciting what they're sharing. I'm just excited that we get to be consumers of it. So I'm Catherine McGarvey. I'm SVP of Engineering, and I'm part of the Enterprise Platform Tech team, which is an incredible team serving many thousands of developers at Capital One. So I want to tell you a little bit about our journey and some of our lessons along the way. So the serverless journey for us began in 2017. Our initial focus was to break down monoliths, drive standardization, and accelerate time to market for new features. In early 2021, so then several years later, we looked at how do we adopt serverless compute solutions to modernize the approach to developing applications and to shift from infrastructure to application-first services to eliminate that infrastructure management. The business benefits are actually really clear when you start to do this. Increased innovation, so our developers spend less time on the infrastructure side and more time on the domain-specific areas that we want to focus on as a business. Reducing the cost and complexity of applications, a smaller amount of code, less code to manage, and improving performance, enhancing reliability, and improving quality. These were all the side effects of trying to get out of the business of managing infrastructure. So by pushing application to utilize existing abstractions, so not trying to necessarily build our own, but utilize what AWS was providing for us, the app development teams could spend less time on establishing and tracking SLOs, thinking about their environment and thinking about the configuration for that environment, and more time on their applications. So how did we do this? And how did we sort of encourage the buy-in that's needed? We established a number of guidelines. So functions first. Developers will prioritize the use of Lambda or functions as the default for building applications. A major shift in how we were thinking about the design of the application itself. And we'll continue to explore that everywhere they can. Containers everywhere else. So we're talking like pushing up the stack wherever possible here. Backend as a service where possible. And orchestration driving maturity. Developers will use orchestration tools and services that enable workflows and messaging among the destination serverless adoption. Pursuing event-driven architectures wherever that made sense. These frameworks lead to simplicity. So standardizing, sharing that standardization was a key part here, and enabling pre-built components to exist. And then keeping that productivity benefits front and center. You're doing all of this work. It's important for you to feel the impact of that work and change as well. This encouraged greater adoption of Lambda by establishing it as the default with justification required. So we sort of said it's default. If you want to drop down to a lower layer of abstraction, you have to explain why you need to do that. So it creates a fairly healthy push up that stack, and making that the default really encourage the right behavior there. We did this recognizing that not just developers had to buy in. Capital One has a unique way of doing strategy, and part of sharing out this approach was to actually get all the business partners bought in and everyone understanding the value of this change. So when we worked through this, people that were perhaps less technical could ask the question of, are you using Lambda for that? Because now they had a knowledge of this space, and it encouraged really healthy checks and balances there. And then to encourage this to sort of happen, we looked at introspection and feedback. And so part of doing that was creating a maturity assessment. And the first level in the maturity assessment was no serverless, level 0. I think we know what that one means. Level 1 was ad hoc. There were pockets of serverless, not because it had been really thought through, but it was just there, someone sort of identified a use case for it. Opportunistic, people were starting to think about the opportunity and the availability of where serverless could fit in. Systematic serverless, this was the default choice. It was part of the design phase, part of the architecture. And then optimized serverless. It's the preferred choice for all use cases. And we sort of assessed and provided feedback so we could keep the conversation at the level, pushing teams to explore where it made sense. As part of doing this, we also identified several architecture patterns. Things like real-time processing, data processing and transformation, integration work, workflow and event processing, APIs, machine learning, and backend as a service. We kept pushing to see what patterns exist and started exploring, hey, does your architecture look like this? Should it look like this? And sort of started to share that feedback across the teams. We also simplified our release pipeline to do this. So if you're adopting a serverless architecture and you're using one of these standardized patterns, well, this is what your load balancer should look like. This is what your other services should look like. This is what we recommend as your default. And instead of you having to start from scratch, here's a pre-built pipeline for deploying it. Our serverless initiative has fundamentally transformed infrastructure management across all of Capital One by leveraging AWS Lambda. And again, we shifted sort of left and pushed the team upwards, but where it made sense, we allowed that to drop down. ECS Fargate, we've streamlined cloud-native compute management, achieving significant improvements in productivity, control, and performance. We've empowered our teams to focus on application development while reducing their infrastructure load and focus. Those cloud-native services have demonstrably improved efficiency and performance, resulting in the following. The run the engine costs has been reduced up to 40%, significant. The scale that we're operating, that's a significant change for us. Cost reduction up to 80%. And again, this is thinking about where you put your costs and your time in your development and your runtime and where you can optimize there. And vulnerability avoidance. So again, pushing up that stack and utilizing this higher leverage of abstraction and really getting the benefits Nick was talking about from a vulnerability standpoint has enabled us to avoid up to 80% in some cases in the managed infrastructure case. It's also enabled enthusiastic adoption. I have to do less as a developer if I do it this way. Less as a developer maybe on the areas I'm less excited about, and maybe to put it. More on the areas I enjoy doing and where my domain and my expertise and my SME sort of factors in. This approach has managed cloud-native services, the managed databases, have enhanced application scalability while reducing operational complexity. So what did we learn going down this approach? And if you're heading down this path, what would I recommend to you? I think, like in all things, you want to start small. We wanted developers to familiarize themselves with the ecosystem, with what it looks like to use serverless compute. And so we talked about that framework where we could start to see it slowly starting to spread throughout the group. And we wanted to spend the time to explain why the architecture needs to change. You're not just swapping out a runtime here, you're thinking about what the use case is, what style it should be, what are you optimizing for as part of doing that. And we encouraged experimentation in this space. The second area we really looked at is master local development tools. We've seen tools like AWS Service Application Model help teams test and debug their applications before deployment. The goal for dev teams is to be able to write all their Lambda functions locally and get that real-time feedback as part of doing that, able to iterate quickly that way. And lastly, we looked at really implementing standards early from the outset. As you create standards, like all things, if you're too far removed from the development team, your standards will be too abstract or not applicable, and it won't take that learning into account. So things like function timeouts, memory settings, understanding the pricing models, logging, and monitoring tools effectively to get the benefit out of the approach. And then as we make improvements, sharing those improvements out as well. Ensuring engineers are aware of AWS-specific practices like CloudWatch log. There's quite a few of these, retention policies, and using the correct versions of SDKs, and checking to make sure we're updating as we utilize those as well. And providing teams with the new resources they need to stay informed about changes. We have a large developer base, so keeping that team on the latest and greatest, keeping them informed of the changes, and then tracking that they're adopting it does take a bit of work to do, but again, it's better than taking on that management and not getting those updates. Great. And so I'll pass it back to Nick.
Okay, thank you. Is my mic on? Yes. Okay, thanks. I really love that story from Capital One. I love customer stories. Helping all of you be successful in what you're trying to accomplish is what gets me going every day in this job. I wanted to share just a couple of other really nice customer stories. The first one is actually probably the one that I like to highlight the most here with DoorDash. So you may actually remember this if you're a football fan, American football fan. I think it was during the 2023 American Football Championship. They ran this promotion during the game on TV. And they wanted to process a huge number of entries for this. I think it was like a contest or something. And so they used an event-driven architecture with Lambda to scale up and process 10 million entries in a period of 5 hours. And what's really amazing about this is this was not some sort of like persistent application where they had to go provision and manage a bunch of infrastructure for a long period of time. They scaled up for the event and then scaled back down to 0. That's the kind of thing that you can do with serverless. You don't have to think about an application or a stack as a permanent thing. You can build something even for just like a one-time use. Scale up, scale down, you're done. So I really love that story. They actually won awards for this campaign that they did. United is another one that I like to talk about, United Airlines. You don't always think about an airline as being a tech company, but airlines are increasingly becoming that. The ability to deliver superior customer experience through things like a mobile app and be able to respond to the changing conditions out there in the travel market are super important. And so United adopted Fargate for their mobile application, and they were able to dramatically improve the speed of implementation of features and ship new features much quicker than they were before. We've got some other really nice examples on this slide here that I'm not going to go into detail, but I just wanted to highlight some of the different kind of outcomes that customers in different industries are achieving with serverless, helping them move faster. A question that we get a lot is, what can I run on serverless? What kind of applications are best for serverless? What can I do with serverless? And the answer is that there's just a huge gamut of things that you can run on serverless. We tried to highlight some of the most common ones here. The first one is legacy app modernization. What does that really mean? You might have a monolith, right? Like a code base that might even have existed since before the cloud. That's a whole bunch of code all in one giant monolith. And you want to get that into the cloud. You want to modernize it, meaning break it out into microservices and event-driven architecture so that you get the benefits of agility, you get the benefits of scalability. Well, serverless is a really good use case for modernizing. We see a lot of customers that when they migrate to the cloud, they also modernize and adopt serverless at that same time. Web applications, which is kind of an amorphous term, but if you're like rendering web pages, you're handling a complex back-end transactions for websites and web applications. That's another really common use case for serverless for functions and containers. Data processing. What does data processing mean? Some examples are things like image resizing or data preparation for machine learning workloads where the amount of data that you have to process might vary a lot. Like maybe in some times of the day of the week, you've got tens of thousands or millions of files to process, and other times you have nothing. With serverless, you automatically scale up and down based on the amount of data to process with low latency the whole time. So that's really popular for like ETL and batch and other types of data processing. One that's maybe not as exciting, but also really useful is just plain old IT automation. Like every time an instance shuts down in our account, we want to go do a bunch of steps after it shuts down to make sure that we're doing the right things. Go trigger a Lambda function based on the event bridge event that happens when that instance shuts down. That's a simple example of IT automation. AI. Everybody talks about AI, so it's a lot in the news, of course, for good reason, right? There's some really groundbreaking stuff happening with Gen AI. But if you look at the kind of things that you need to do to go implement AI, ML applications, There's a lot of data transformation. There's a lot of like workflows that have to happen. These are all things that are really well suited for serverless. So we see a lot of customers doing that. I'll talk a little bit more about that on the next slide. In particular, when you think about generative AI and the types of applications and the types of software that you can write with generative AI, and I don't just mean things like using a coding assistant to write code. I mean things like what we're seeing now with agents and the things that Bedrock agents are enabling. When you look at those types of applications, the resources that they use and the interactions that they go through are more fluid than a sort of more standard type of application that's written with code that's written by a developer. And that means that the resource needs and the scaling are just going to be even more dynamic and fluid than they've been in the past. And we think serverless is really well suited to run those types of applications. So as you look at infusing more and more generative AI across your enterprise, I think you should, if you're not already using serverless for those use cases, I think that's one that's worth considering. Also shows up in places like RAG, retrieval augmented generation pipelines, where you're like processing documents and putting them into a vector database. We see a lot of functions using step functions for those kind of workflows. So it's really showing up all over the place in generative AI workloads. And talking about the future, people often ask, okay, serverless is 10 years old. What's going to happen in the next 10 years for serverless? And I don't have a crystal ball. I can't predict the future. I don't know what's going to change in the next 10 years. But I can tell you what's not going to change in the next 10 years. People aren't going to want a more complicated developer experience. They aren't going to want less well-architected fundamentals, right? They aren't going to want more complicated controls over their services. They aren't going to want fewer integrations. And so the things that we're doing on serverless that are focused on these areas, we know that you're going to want more and better of those things over the next 10 years, and that's what we're going to keep doing. The way we do those and the specific technologies that are involved, we don't know. Like, things are going to change. There will be new technologies that emerge that no one is thinking of today, and we'll make those things work with serverless. But the core principles are not going to change. And so that's what I say when people ask me what's coming and what's going to change, what's happening over the next 10 years. So with that, I'll end it. Thank you very much. Really appreciate, and we do have some time for Q&A here as well. Please do make sure to complete the session survey in the mobile app.